Hello, AP Calculus students, to day 5 of reviewing the free response questions for the AP Calculus AB exam. Today we're going to be looking at another question, but before that, as usual, let's try a little bit of a warm-up, and then we'll get to the main focus of today. So, we have a bell ringer here. The graph of G shown below consists of the arcs of two quarter circles. All right, so we're told that these two curved parts of the graph are quarter circles. So that's a quarter circle. This is a quarter circle. And then we're told two straight line segments. So just to make sure that nobody is unsure whether these are straight, these are indeed straight lines. So that is a straight line segment. That is a straight line segment. The value of the integral from 0 to 12 g of x dx is blank. So remember that one definition of an integral is the area between the function, in this case g of x, and the x-axis. So the area between g of x and the x-axis, so that's what we're going to find. So first off, let's do this quarter circle first. All right, let's do this quarter circle first. So that quarter circle is going to be, it has a radius of 4. Okay, it has a radius of 4, so that's going to be pi r squared. Remember, the area of a circle is equal to pi, I have no idea why I wrote 2. Pi r squared. So a quarter circle is just going to be pi r squared divided by 4. So we have pi times 4 squared divided by 4. Okay, so we have that part. Plus, now let's do this triangle, right? We have a triangle here. Now it's below the x-axis. This triangle is below the x-axis. So recall that means that area number is going to be negative. So let's see, we have a base of 2 and a height of 3. So a base of 2, height of 3. So that's 2 times 3 divided by 2. So 2 times 3 divided by 2. And then we have another quarter circle here. So highlight that. We have another quarter circle here. We got that. All right. So it looks like the radius of that circle is 3 this time. So this time we have pi times 3 squared divided by 4. And then finally we have another triangle. We have another triangle for our final figure. We have a triangle here. All right, triangle here. So it looks like the base of that triangle is 3, and the height of that triangle is 5. So 3 times 5 divided by 2. So 3 times 5 divided by 2. So just to recap here, the first figure, we had that quarter of a circle. Our second figure, we had that triangle. Oop, forgot to make it negative. Good that I went over this. It's negative since it's below the x-axis. Same thing goes with that quarter circle, which is next. And then finally that fourth figure, that triangle, is above the x-axis, so it's positive. So there we go. So now I just got to simplify these, see which one matches the choice. So pi times 4 squared, so that's 16 pi. 16 pi divided by 4 is just 4 pi. All right, so we got that. The 2's cancel out here, so we'll just end up with negative 3. So pi times 3 squared, so that's 9 pi over 4. So negative 9 pi over 4. And then we have 15 over 2. 15 over 2. So it looks like we have to simplify this a little bit. So let's combine the terms with a pi. So we have 4 pi, and we have 9 pi over 4. Well, remember 4 pi was just 16 pi over 4. So I'm actually going to rewrite it as 16 pi over 4 so that the denominators are the same. So 16 pi divided by 4. So if we were to combine those two, it would be 16 minus 9. So that's 7 pi over 4. 7 pi over 4. And then we have negative 3 plus 15 halves. Negative 3 plus 15 halves. Well, negative 3 is the same thing as negative 6 over 2. Negative 6 over 2. So that's negative 6 plus 15, so that's 9. So it's 9 halves. So it looks like our answer is 7 pi over 4 plus 9 halves, which looks to be answer choice B. So 7 pi over 4 plus 9 halves would be our final answer. So a pretty straightforward problem, not too difficult, just finding the integral by calculating the area between a function graph and the x-axis using quarter circles and triangles. All right. Hopefully that went well. Hopefully that went smoothly. Hopefully you got the same answer. So now let's move on to today's free response question. Now, right off the bat, you'll notice that we're working on question 6. Now, the reason why we're working on question 6, even though our last question was question 4 that we worked on, is because question 5 involves the unit that this year's AP Calculus exam will not be covering. It is the unit that got cut off that we would have covered, that would have been our final unit of the year, but since they cut it off for the curriculum, I decided to focus on just what we had to cover for the AP exam. So as a result, I skipped number 5 and we move on to number 6, which will involve topics that we would have covered over the course of the year. So let's get to it. So functions f, g, and h are twice differentiable functions with g of 2 is equaling h of 2, which equals 4. The line y equals 4 plus 2/3. The quantity x minus 2 is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. All right, so part A, find h prime of 2. Find h prime of 2. So this is asking us to find the derivative of h at 2, or in other words, this is asking us to find the slope of h at 2. So the slope of h at 2. All right, well, let's see. What is the slope of h at 2? Well, remember another definition of the derivative is the slope of the tangent line. More specifically, the slope of the tangent line of h at 2. Well, that second sentence in the problem tells us the line tangent to h at x equals 2. It's this equation. This equation is the equation of the tangent line of h at 2. So, what is the slope of this line? Well, if we were to distribute this 2/3, we would say that the coefficient of x is 2/3. And remember, in y equals mx plus b form, slope-intercept form, y equals mx plus b, the coefficient of your x term in the equation is your slope. The coefficient of the x term in your equation is your slope, which means the slope of h at 2 is 2/3. And that's it. That is all you would have to do for this problem. So this one is more just recalling the definition, remembering the definition of what a derivative is. You'll see on the scoring rubric that this question is only 1 point, and it makes sense. It's pretty short and simple. So that's all you would have to do. It's just 2/3. All right, let's look at B now. Let's look at B. So B says, let A be the function given by a of x is equal to 3x cubed times h of x. Write an expression for a prime of x. Find a prime of 2. All right, so it's telling us to take the derivative of a of x. So let's do that. Let's take the derivative of a of x. All right, so a prime of x. So we have 3x cubed times h of x. 3x cubed times h of x. So we're going to be doing the product rule for this. So we're going to take that first function, 3x cubed, multiply it by the derivative of the second function, so h prime of x, plus the derivative of that first function, 6x squared, 9x squared. 3 times 3 is 9, not 6. 9x squared times that original second function, so h of x, okay? So just to recap, the first function times the derivative of the second function plus the derivative of the first function times the second function. So that is the product rule, and that's what we got. So now we want to do this at 2, so h prime of 2. So we're going to do h prime of 2. So let's see, we have 3 times 2 cubed times h prime of 2 plus 9 times 2 squared times, don't want to be in the middle of the paper, times h of 2. Let's see, so 3 times 2 cubed is 8. 3 times 8 is 24. H prime of 2, let's see if we can find h prime of 2. h prime of 2 we found in part A, which is 2/3. So 2/3 plus 9 times 2 squared. 2 squared is 4. 9 times 4 is 36. And then we get h of 2. We are told in the problem h of 2 is equal to 4. All right, so let's see if we can simplify this. So 24 times 2/3. Well, let's see, 24 is just 24 over 1. The 24 and the 3 simplify to an 8 and a 1. So we got 8 times 2, which is 16. 36 times 4 is 144, I believe. So it looks like our final answer is 160. It looks like our final answer is 160. Now, really quickly, just remember a word of caution. Remember, you don't have to simplify this. Had you stopped right here, your answer would have been perfectly fine. So you could have left it as 24 times 2/3 plus 36 times 4. That is a numerical answer. There's no variables. There's no function notations in it. That is a numerical answer, and that is perfectly fine as your final answer. I simplified it because I just like seeing things simplified, but you do not need to simplify this. So even if you didn't get 160, even if you got what I pointed out here, that's perfectly fine as well. All right, so that's B. So that's just knowing your product rule. Knowing your product rule gets you to answer to B. So now let's look at C. So C, let's see. The function h satisfies h of x is equal to x squared minus 4 over 1 minus the quantity f of x cubed for x not equal to 2. It is known that the limit of h of x as x goes to 2 can be evaluated using L'Hopital's rule. Use the limit as x goes to 2 of h of x to find f of 2 and f prime of 2. Show the work that leads to your answers. So show the work that leads to your answers. All right, so let's see. Let's try to figure out how to determine this. So we're told we can use L'Hopital's rule to find f of 2 and f prime of 2. All right, well, let's try this out. Well, let's use L'Hopital's rule. Well, in order for L'Hopital's rule to apply to this, just remember, L'Hopital's rule is used when you get an indeterminate form. So, for example, 0 over 0 is an indeterminate form, infinity over infinity is an indeterminate form, and so on and so forth. So let's see. Well, right off the bat, it looks like our indeterminate form is going to be 0 over 0, because if we were to just take, so the limit as x goes to 2 of x squared minus 4, we would get 2 squared minus 4, which is 0. So that means, that implies, since the problem is telling us that we can use L'Hopital's rule, that implies that the bottom is also going to be equal to 0, right? That implies that the bottom is also going to be equal to 0, because the only way L'Hopital's rule to apply here is to have 0 over 0. So that means the limit as x goes to 2 of 1 minus the quantity f of x cubed has to equal 0. And actually, so that means 1 minus f of 2 cubed has to be equal to 0. Well, we can actually quickly solve this pretty easily. The only way that this would be equal to 0 would be if f of 2 would be equal to 1, right? 1 minus something cubed is equal to 0. The only number that would work would be 1 cubed. So that means f of 2 would have to be equal to 1. So we found f of 2. Now we have to show f prime of 2. All right. Well, f prime of 2, we're going to have to figure out by actually taking this limit. So let's do the limit as, as x goes to 2 of h of x. All right. So we're going to, since we're already told that we can use L'Hopital's rule, and we actually already showed here that we get 0 over 0. So now we're going to do, we're going to use L'Hopital's rule and actually take the derivative of the top, take the derivative of the bottom. So let's do that. So remember, L'Hopital's rule says that if you get that indeterminate form of 0 over 0, we can take the derivative of the numerator and the denominator. So we get 2x minus 4. And then on the bottom, let's see, on the bottom, the The derivative of a constant is 0, Mihawk, just 2x. And on the bottom, we're going to get negative, we're going to use the power rule here, 3, because we have a cubed and then an f of x. 3 times f of x squared, right, the exponent comes down, becomes a 3, subtract 1 from the 3, times the derivative of the inside. I'm not going to make that mistake like I did last time where I forgot about the chain rule. We have to multiply by the derivative of the inside, and our inside function is an f of x. So that means we multiply by f prime of x. Well, let's see. Well, remember, we can use... wait a second here. Okay. We can use, or we can plug in 2 now. So let's see, we get 2 times 2. And then we get negative 3 f of 2 squared times f prime of x. All right. Or f prime of 2, sorry. F prime of 2. Let's see, f prime of 2. Okay, we got that. And we know f of 2 is 1. So that gives us 4 over negative 3 times 1 squared. So negative 3 times f prime of 2. Okay, we got that. So let's see, what are we missing here? What are we missing here? So it looks like homogeneous satisfies continuous everywhere. I'm trying to think, what am I missing here? What am I missing? So we took the limit. Okay, I think. All right, let's see. Let's try to figure this one out together. So we got that. Okay. I think I figured it out. All right. So we're told in the beginning of the problem that h is differentiable. And remember that if something is differentiable, that implies that it's continuous. All right. So h is differentiable. Which implies continuity, all right? So h is differentiable, which implies continuity. Now, if you recall, in order for something to be continuous, the function value, so let's say h of 2, has to be equal to the limit as x goes to 2 of h of x, okay? So h of 2 has to be equal to the limit, so the function value has to be equal to whatever the limit is equal to. Well, we're told that h of 2 is equal to 4. We're told that h of 2 is equal to 4. So that means this expression that we've been trying to figure out, which is the limit of h of x as x goes to 2, has to be equal to 4. So 4, we're to bring this over here, 4 h of 2, which equals to 4, would have to be equal to this expression 4 over negative 3 times f prime of 2. Well, let's quickly solve this. We can bring this to the other side by just multiplying by negative 3 times f prime of 2. So this becomes negative 12 times f prime of 2 is equal to 4. So that means f prime of 2 is equal to negative 1/3. F prime of 2 is equal to negative 1/3. Or was it, f of 2 is equal to 1. F prime of 2 is equal to negative 1/3. Okay. Okay. So once again, this one was a tricky one. I did have to think about it for a few seconds. Finding f of 2 wasn't too hard, just knowing that since it was L'Hopital's rule, that means you had to get that 0 over 0. But then remembering that since the original problem told us that h of 2 is equal to 4, and that it was differentiable, in order for it to be differentiable, the limit would have to be equal to the function value, which is exactly what we set up here, right? The limit is equal to the function value. All right. Let me just make sure one last thing. All right, cool. I'll find f of 2. Find f prime of 2. All right. Cool. All right, so we got that. I think the only thing, they might sometimes be picky on when we took the limit here as x goes to 2 for 1 minus f of x cubed. The only thing you have to be careful of is this works as long as, or we can say that the function value is equal to the limit as long as it's continuous, much in the same way where we pointed this out. So you might have to say, since f is also differentiable, so I would probably say, for just to be safe, that since f is also differentiable, which implies continuity, we can say that f of 2 is equal to 1, since the limit tells us that. That is one thing I would probably add just to be safe. I like to think they probably wouldn't take off if you did not say specifically that. This is probably important, but for the F1, probably not. All right, now let's move on to D. Let's move on to D here. All right, let's see what we got here. It is known that g of x is less than or equal to h of x for 1 less than x less than 3. Let k be a function satisfying g of x is less than or equal to k of x is less than or equal to h of x for 1 less than x less than 3. Is k continuous at x is equal to 2? So is k continuous at x is equal to 2? Well, let's see. So we have to determine if it's continuous at that value. And we're told that k of x is always between g of x and h of x. So this is a perfect example of a problem, of a topic that I wanted us to cover, actually. It's a topic called squeeze theorem. Squeeze theorem, if you want to look that up, even on Khan Academy, I think they have a pretty good video on it. Squeeze theorem. And squeeze theorem basically says that if you have a function that's always between two functions, then you can start to make certain conclusions about them. So for example, we are told that, let me see. Yeah, we are told that g of 2 and h of 2 is equal to 4. So g of 2 and h of 2 is equal to 4. And we are told that they're differentiable. All right. And recall from part C, since they're differential, that means they're continuous. Okay. So let me start it off by saying, so what was it, g and h? Make sure for D, g and h. Okay. So g and h differentiable, which implies they are continuous, which means since both g of 2 and h of 2 are equal to 4, that implies that the limit as x goes to 2 of g of x is equal to g of 2. And then the limit, and basically what we concluded in that previous part C, as x goes to 2 of h of x is equal to h of 2. So what does that mean? Well, the key part is this. We can say that since this is true, well, then the following has to be true. The limit, where is it? Yeah, I'm going to start it off by just saying this. So g of x is less than or equal to k of x, so less than or equal to h of x. Which means that the limit as x goes to 2 of g of x is always going to be less than or equal to the limit as x goes to 2 of k of x, which is always going to be less than or equal to the limit as x goes to 2 of h of x. Okay? And we know that those limits are equal to 4. So x goes to 2 of k of x. And 4. Well, based upon that, that means the limit for k of x has to be equal to 4, right? I mean, what other number could be less than or equal to and greater than or equal to than 4? So that means the limit, and you don't have to specifically say the squeeze theorem here. You can just show these inequalities. That means the limit as x goes to 2 of k of x has to be equal to 4. Has to be equal to 4. And as we pointed out before, now I'm going to use this part. G of 2 would have to be less than or equal to k of 2, which would have to be less than or equal to h of 2, for less than or equal to k of 2, less than or equal to 4. So that means k of 2 is also equal to 4. So that means the function value is the same thing as the limit value. Hence, we can conclude, going back to the original problem, we can conclude that k is continuous at x equals 2. K is continuous at x equals 2. So squeeze theorem, if you want to look that up on Khan Academy, squeeze theorem is what you want to look up. Once again, it's a topic that we did not explicitly cover over the course of the year. It's not, at the same time, I will admit, it is a topic that's not rarely seen, that is rarely seen. I mean, the 2019 had a question with the squeeze theorem, but if I recall, the previous year had no question with the squeeze theorem. But it all has to just, it's not a difficult concept to grasp, just this idea that if the function is always between them, that means the limits are always between them, and so on and so forth. So if you're between 4 and 4, that means you're equal to 4. So it's just about knowing the implications of what it's saying. Okay, so that was today's free response question. It was actually the last free response question from the 2019 AP Calculus AB exam. Once again, we skipped number 5 because that one had dealt with the unit that we ended up skipping this year. So next, for our next lesson, we will be covering something different. But otherwise, I hope this video went smoothly in terms of an assignment. Our next assignment, we're just going to continue with our journey through calculus. You will be working on page 5. We're almost done with it. Okay, so we're almost done with that journey through calculus. So page 5 of journey through calculus. Once again, it will be extra credit if you complete it. As usual, just take a picture, email it to me. Always let me know if you have any additional questions, guys. I try to give some pretty specific feedback whenever you turn in any assignments, as those who have hopefully seen. If you email me something, I typically email it back to you with some pretty specific things that you either did right or wrong. All right. Well, I hope you guys are staying safe. I hope you guys are staying healthy. And I hope you guys enjoy the rest of your days. See you later.